Hello and welcome back to Functions. In today's part 3, we will continue speaking about another type of functions, specifically rational ones. However, before we get to that, first I want to thank all the nice people that support this channel by liking and subscribing. Now, a rational function is any function that can be expressed as a quotient, hence a ratio, and hence it's called rational. The general format would be y is equal to f of x divided by g of x. So now, of course, a must-have condition here is that g of x cannot be equal to 0 because division by 0 is impossible. And the next condition is that both f and g are polynomials. However, most of the rational functions that we'll be working with, both the upper and the lower part, is either going to be a number, it could be linear, or could be quadratic functions. So technically still polynomials, just simpler ones. For example, the very popular one called the reciprocal function, it's 1 over x, where x does not equal to 0. This is a rational function. In this case, the numerator is just a number, and the denominator is just x. So they're both technically polynomials. Now, looking at this example, there are values which we can exclude from both x and y. So that means there's going to be a number that we can exclude from both the domain and range. Automatically, of course, we already know that x does not equal to 0. Now, another one that we can see, maybe you can see, maybe you can't, but it's that y also can't be equal to 0. It is simply impossible. We can verify this by taking the limit as x approaches infinity of 1 over x. What we get at the end is going to be 1 divided by an infinitely huge number, which at the end is just basically 0. It is also a reason that the graph of 1 over x never touches the x or y axis. It will definitely get infinitely close to both of these x and y axes, however, it will never intersect them. So in this case, the domain and range are going to be the same. So x and y both cannot be 0. However, there are two ways to express this. Of course, the simple one for domain, you can just write that x doesn't equal to 0. A more mathematical way to express this would be x belongs to all real numbers excluding the number 0. And of course, we can also write the same thing for the range. Y belongs to all real numbers except for one number, which is 0. Now, coming back to the graph of 1 over x, the next thing you might notice is that at the ends of the graph, like I mentioned before, it will get infinitely close to the x and y axis. For now, I will mark them as dotted red lines. These are the lines that our graph will never cross or touch. And these lines have a special name, and they're called asymptotes. And of course, for our graph, we have a horizontal asymptote, in this case, y equals to 0, and we have a vertical asymptote, x equals to 0. To understand a bit more about this, let's take a look at another example. We have a rational function given by y equals to 2 divided by 1 over x. Let's begin by stating both the domain and the range of the function, and then we'll be able to graph it. I always like to begin with the domain. In the denominator, we have 1 minus x, and we know that this thing cannot be equal to 0. So that tells us that x cannot be equal to 1. So hence, the domain is going to be x belongs to all real numbers except for that 1. What this also means is that we will have a vertical asymptote, which I'm going to write as VA, at x equals to 1. This is going to be that vertical line which our graph won't ever cross. So let's plot this on a graph first. Next, let's figure out the range, which will give us information about the horizontal asymptote too. Logically, it is quite clear that we can't get a 0 for the y, because the only way that's possible in a fraction is if the numerator is equal to 0. But our numerator isn't made up of a function, it is made up of just a number 2. Of course, the analytical way to solve this, just as mentioned before, you can take the limit. In this case, you can actually take the limit from both sides. So that means x can approach positive infinity or negative infinity of our function 2 divided by 1 minus x. And of course, the value we're going to get is 0. Now, if you don't remember how to do this or don't know how to do this, check out the other playlist called Calculus and then watch the second video about calculating limits. So that means for range, y is going to belong to all real numbers except for our 0. And this also means that we have a horizontal asymptote, which I'm going to write as HA at y equals to 0. And I will plot that on our graph too. And then we can plot our function by simply finding perhaps a few points that belong on the graph, and you will find it out. The hack for plotting rational functions is that they all have the same shape. It's either going to be in the first quadrant and the third quadrant, or it's going to be in the second quadrant and the fourth quadrant. It's either this or that. Very rarely is it going to be both curves on the upper side or both curves on the lower side. Of course, just to be sure, you can always check where the points are, and I think the easiest point to find would be if there are intersections with the x or y axis. In our case, it's only with the y axis because it cannot cross the x axis. Or of course, you can also find any points by plugging in some easier values of x and then finding y. So I think that's it for today, but of course, we aren't done with rational functions yet. In the next video, as part 2 of rational functions, we will cover more difficult ones, and I will show you a few more tricks. So that's it for today, and I hope you have a nice day. Bye!